Good to see you all again in the lecture series video for the course Measurements and Instrumentation. This video is taken by Bharat, STEM Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. The course what we are just seeing is the course Measurements and Instrumentation. In unit number 2, which is comparative methods of measurement, in the last class we just discussed about the DC potentiometers, which remains the first topic in comparative methods of measurement. We just discussed what are the various methods are used, what are the various types of DC potentiometers, how the DC potentiometer work, what are the various applications of DC potentiometer, and so on. In today's video, we are going to start with something called as bridges. Especially, we are going to see DC bridges and what are Wheatstone's bridge. Wheatstone's bridge is one of the classification of a DC bridge. Come, let's get into the video. Let's recall what are the things we have just discussed. We have just discussed about the various concepts of DC potentiometers. We are going to discuss about the bridges and measurement in the last case. The general principles of DC potentiometer we have discussed in the last class. What are the purpose? What is the empathy part? What is the basic structure? The balance condition and advantages. Empathy. Why we need a Wheatstone's bridge? Resistance measurement in engineering foundation, the resistance measurement is a very important part. Resistance measurement is essential in electrical engineering for any applications. Resistance being the basic standard. So this method uses a null deflection method. It compares with some known values. It gives the values of an unknown quantity. It has the fundamental circuit theory with applications, structural health monitoring system, and career opportunities in the bridge design is very high. Now coming into the basic circuit of a Wheatstone's bridge. It is one of the classification of a DC bridges. What is a bridge? A bridge may consist of 4 arms. Out of the 4 arms, 2 arms is a known value of resistance, which is constant. 1 is a standard or a variable resistance, and 1 value is an unknown quantity. You can see the Wheatstone's bridge, which is balanced, that is 4 resistance values connected to a source of 10 volt. When all the 4 resistances R1, R2, R3, and R4 are equal, that is 350 ohms, then it is said to be as a balanced system. That is called as a balanced Wheatstone's bridge. So this is also called as a diamond configuration. The galvanometer detects the balance condition, and whenever it reaches 0, we can measure the value. But always a bridge will not be in a balanced condition. We have to make the bridge balanced by changing some known value of resistance to find out the unknown value of resistance. So the working principle of a Wheatstone's bridge, the balance condition is the main concept over here. Galvanometer should read 0 deflection. When the galvanometer will read 0 deflection, when the 0 current flows through the galvanometer, when the galvanometer reads 0, that is, when does this current flows 0? When we vary the variable resistance R3 until the balance between all the 4 resistances, that is a bridge balance condition, is arrived. What is the formula for bridge balance condition? That is R1 by R2 is equal to R3 by Rx. Where Rx is the unknown value of resistance, we are going to measure the unknown value of resistance. That is Rx is equal to R3 into R2 by R1. The key point is when ratio balanced, VA is equal to VB. There are various applications of Wheatstone's bridge. Understanding the concept of Wheatstone's bridge is used to apply at various places like force or stress measurement, that is like strain gauges. Temperature measurement, where we measure the RTD temperatures in different applications. We have also seen about the modified bridge balance condition. That is, we have Maxwell's bridge to measure the inductance We have Kelvin's bridge to measure the low resistance measurement. Various modifications are done in this simple Wheatstone's bridge to measure different values at different point of time. You could see the practical application of a Wheatstone's bridge setup. Panel modeling is done and it is shown over here to find the variable value or the unknown value of a resistance. The next level, Kelvin's bridge, is shown over here. So what did we see in the last video? Is the null deflection concepts, zero current, bridge balance formula, the precision and applications of Wheatstone's bridge. As a summary, we have discussed about what are bridges and what are the various measurement systems used for bridges. We have discussed about how low, medium, and high resistances are measured using a Wheatstone's bridge. The concepts of Wheatstone's bridge, the working principle of a Wheatstone's bridge, and the various applications of Wheatstone's bridge. With this, we come to the end of the video. Next video, we'll discuss about the next level of bridges that could be the Kelvin's bridge. Thank you.